The retrofit engine management system allows a modern system to be adapted to an old engine. Hi, I'm Vernon, and this is my project for the Microchip PIC32 Design Challenge, the retrofit engine management system. First, let's take a look at the hardware. Three key goals for the REMS prototype are low cost, a small size, and minimum hardware complexity. These goals are achieved by fully leveraging the power of the PIC32, keeping parts count to a minimum. The simple low-cost two-layer circuit board is populated on only one side. It was accomplished in a very small 4x6 inch footprint. So how does leveraging the power of the PIC32 help to keep the hardware simple? Well, for example, there's very little in the way of signal conditioning for the analog inputs. The number of devices on the REMS prototype circuit board are kept to a minimum, in part by leveraging the numerous onboard peripherals that are featured in the PIC32 device. On the output side, we go directly from the PIC32 right into the power MOSFETs, no intermediate stage between them, except for the sequencing control for the fuel injection. Okay, so that's the hardware. Now let's see about the software. Here we see the system in operation on the test bench. These are the UART ports. UART1 is currently in use. UART2 is available for additional diagnostic monitoring. This breadboard here is our basic input simulator. 8 potentiometers for the analog inputs and an 8-position dip switch for the digital inputs. In order to visualize what the outputs are doing, this breadboard has an array of LEDs, one connected to each output, 16 altogether. Here we see the system is drawing 470 milliamps, and here we show the power supply voltage, typical for an automotive application. Here the oscilloscope is monitoring the 4 fuel injector output signals. The system is running in debug mode through the MPLAB Realize. Here we can see a shot of the MPLAB running on the Vista workstation. A second workstation running Windows XP has the real-time serial terminal emulator running on it right now. The system responds to commands. It's a very short set of commands, and they're all typed out when you type in a question mark or an H for help. Here I'm going to dump the engine speed or RPM buffer. You'll see the numbers are very low. So I will adjust the input potentiometer for that channel. And repeat the buffer dump once again. And you see now the numbers have increased.